Hi, this is Feynman Education, and today we're back explaining IB Chemistry, subtopic 1.3, reacting masses and volumes. So the first subsection is the limiting and excess reactant. So the three definitions that we need to remember in this subtopic is the first one is theoretical yield. Theoretical yield is just a term to describe the maximum quantity of products that can be obtained from given quantities of reactants, assuming completion. So this means when a reaction happens, theoretically or on paper, we're supposed to get this much amount of product, but in real life we don't really get that because of practical issues, equipment problems, or just the procedures alone. We can't really get 100% efficiency. And the second definition that we need to know is the limiting reactant. So the limiting reactant is the reactant that determines theoretical yield of a product. After the reaction, there will be none of this reactant left. So this is the one is reacted completely in the equation, and the other reactant will be the excess reactant, which is not used up completely by the reaction, and after the completion of the reaction, this substance will still be present in the mixture. So usually the question that they want to test you in the IB, they give you the amount of the number of moles for each of this reactant, and then decide which one is a limiting, which one is an excess reactant. And you can compare these number of moles based on the ratio given in the reaction equation. After these definitions, we'll do one example question underneath is coming up right now. Okay, so then the example question. We have is 0.2 mole of hydrochloric acid is mixed with 0.2 mole of calcium carbonate. So here they give you the number of moles, but sometimes they give you the amount in mass, so you just have to convert it into number of moles and then compare. And in the equation, the ratio between hydrochloric acid and calcium carbonate is 2:1. So we just need to compare the number of moles of hydrochloric acid divided by its ratio, which is 0.2 divided by 2, which is smaller than 0.2 divided by 1, which means the smaller amount is the limiting and the bigger amount is the excess reactant. And we know that the limiting reactant is hydrochloric acid. We use that to plug into the equation, which means the number of moles of carbon dioxide is 0.1 mole. So C is the correct answer. Alright, so then the next subsection in this subtopic is about ideal gases and gas laws. So ideal gas is a theoretical gas, which means that this gas is not present in real life. Assuming that the volume of the particles is negligible and no kinetic energy is lost in the collisions between particles. So for example, if we have a gas that is in a container, we assume that the particles don't have a volume, which is not possible in real life. That's why this gas is ideal and it is not a real gas, it's just a theoretical gas. And we also assume that this particle is not moving at all. But as we know from the previous subtopic, topic 1.1, we know that the particles in the gas form, they move constantly. So that means that this assumption is also just for the ease of calculation. So because of these two assumptions, this gas is considered ideal. Okay, so then we need to know the definition of pressure and temperature in order to understand their roles in the ideal gas law equation. So pressure is basically just the force exerted by the collisions of particles on the wall of its container. And the temperature is just the average kinetic energy of. So if the temperature goes up, the particles move more, and if the temperature goes down, the particles move around less. Okay, so then next, after looking at what is the ideal gas, the definition of pressure and temperature, we can finally move on to the ideal gas law, which is the equation PV equals to nRT. And you guys will have this equation on your data booklet at all time, so you can refer to it. But the important thing to remember about this equation is that you need to remember the default unit that we use for all of these measurements. So for pressure, the default unit is Pascal. For volume, we use meter cube. So remember to exchange dm cube to meter cube or liter into meter cube in your calculation. And N is for the amount of substance in mole. R is the ideal gas constant, which is 8.31. K minus 1, mole minus 1, which is also in your data booklet. Temperature is in Kelvin. So Kelvin is equal to Celsius plus 273.